Okay, so just a few words about interfaces, since those are one of the features of Java that I feel worst about having left out of the main lecture strand. So what is an interface in Java? The easiest way to think about it is that an interface is a very abstract class. All its methods are abstract. So recall the abstract class example animal that we had in the inheritance lecture. Our abstract class animal provided an implementation of the sleep method, but it didn't provide any implementations of its other two declared public methods, roam and make noise. And that's typical for an abstract class. It provides implementations of some of its methods, but not all of them. And if it's not going to provide an implementation of a method, then it declares that method to be abstract, just like you see here. And because it doesn't provide implementations for everything, you can't directly instantiate an abstract class. So we can't create an animal without saying what kind of animal it is we want to create. But an animal, or any abstract class, is allowed to provide no implementation at all. So we could, for example, declare our abstract class animal with all three methods abstract, and we might call that a completely abstract class. That's slightly clumsy, and as we'll see later, it has some other disadvantages as well. So instead we can write pretty much essentially the same thing like this using an interface in Java. We'll get rid of all those abstract keywords because interfaces are inherently abstract, you don't need to say so. And we can define a public interface animal with three public methods, sleep, roam and make noise, and none of them are provided with any implementations. How do you go about creating a specific kind of animal given such an interface? Well, we use the special keyword implements. So here's an example. We could create a public class cow which implements the animal interface, and from then on it's very much like extending an animal abstract class in that version. In the case of each method that doesn't already have an implementation, we provide an implementation in exactly the way that you're familiar with. So implementing an interface is very similar to extending a class. The implementing class must provide an implementation for every method of the interface, otherwise you haven't properly implemented the interface. From the point of view of clients, there's really very little difference between an interface and an abstract class. You can do exactly the same things that we already did in the inheritance lecture with abstract classes. Supposing that we know that the class cow provides an implementation of the make noise method, so suppose cows moo, we can create a new cow and we can assign it to a variable which is declared to have type animal. And then we can use that variable to send messages to. For example, we can send it the make noise message, and the actual implementation of make noise that gets executed depends on the runtime type of my animal. In our case here, the result of sending my noise to animal will be to moo. And none of that is any different whether animal is an abstract class like you saw before, or whether animal is an interface. It behaves exactly the same way from the point of view of the client. From the point of view of the client, you really won't care whether the general type you're using is an abstract class or an interface. It makes no difference. Why might you want to use either of them? Well, typically it's all about encapsulation again. For example, supposing that this code fragment here is part of a method which has to return this animal that we created, we might well want to say, well, let's return the thing, declaring its type to be animal, so that the client doesn't get to rely on the fact that we're currently choosing to create a cow here. The client should just know that they're getting some kind of animal. And that way, if we later on decide that we would rather create a horse or a cow or a cat, we can do so, and nothing on the client side will have to change. And again, that makes no difference whether animal is an abstract class or an interface. For that purpose, you can do that, play that trick in either case. You may be wondering, if interfaces are so much like completely abstract classes, why does Java even have a separate concept of interface? Well, really for historical reasons, and basically because multiple inheritance, being able to write a class that inherits from two different classes on the same level, turns out to be such a pain. And we know it's such a pain because C++ did it, and generations of C++ programmers discovered what a pain it is. It's a pain for theoretical reasons, and it's also a pain for practical reasons to work out what you're actually trying to do. And if you want to know more, you can Google things like fragile base class problem, or in fact multiple inheritance C++ will do it. Some of the problems that arise are where you say that you have suppose you inherit from two different classes on the same level. Suppose, for example, we have a houseboat which inherits from house and also inherits from boat. And then we say, actually, house inherits from thing someone owns, and also boat inherits from thing someone owns. Well, at that point, houseboat is inheriting twice from thing someone owns, once via house and once via boat. And that turns out to be really, really painful. Now, because of all the pain that C++ experienced, and because actually multiple inheritance was found usually to be probably bad design, there wasn't really much call for it. In Java, multiple inheritance was forbidden. So in Java, each class only has one direct superclass. You can say class cow extends animal, but you can't say extends animal extends something else. However, sometimes you have a situation where you really would like to inherit from two different superclasses, not because you want to actually inherit any behavior from them, but just because you want to be able to regard your thing as being a special kind of both the things you want to inherit from. In other words, it's really the types that you care about. Now, it turns out that if everything you want to inherit from is completely abstract like that, we're really only talking about types, then those problems that arose in C++ don't arise. And therefore, people wanted to be able to do that. So Java managed to satisfy the desires of those people without getting into the trouble that C++ had experienced in multiple inheritance by saying, we will have interfaces, and you will be allowed to implement several interfaces. And so that's what happens. That's basically why we have both abstract classes and interfaces, instead of just saying, well, an abstract class can be completely abstract. Where you'll mostly see this, for now at least, is in the collection classes. So when you browse around the JDK documentation for the collection classes, and you should, you'll notice that it tells you that hashmap implements the interface map, and that ArrayList implements the interface list, and so it goes on. And part of the reason for that is because it often happens that we want to be able to write methods that will, for example, return a thing of type map without wanting to commit to exactly what implementation of map it's going to be that gets returned. And that lets you do that. Okay, I hope that made some kind of sense. Stop there.